Okay, so for number 1, what do I need to distribute?
2.
The 2. Very good. I need to distribute the 2, which means I need to multiply both terms in here by 2. So 2 times x is?
2x.
2x. 2 times negative 5 is?
Negative 10.
Negative 10. And I cannot simplify that any further. How'd y'all do? Good. For number 2, I have 3 terms. Does anybody know what that's called? Trinomial. Very good. So we need to multiply everything by negative 4. So negative 4 times x squared.
Negative 4x squared.
Negative 4 times negative 5x. Wait, don't answer. Is the sign positive or negative?
Positive.
Good. Positive 20x. Good. Negative 4 times 1?
Negative 4.
Negative 4. That cannot be simplified any further. I do not have any like terms to combine. Any questions? Okay. Number 3. 3x times 2x. When you're multiplying 2 terms like this, you multiply the whole numbers. So 3 times 2 is 6. And then I have x to the 1 times x to the 1. When you multiply powers, you add the exponents. So that is 6x squared. Any questions? No. Now, we talked about a. If it doesn't have an exponent, it's assumed to be a 1. So we just said in problem number 3, when you multiply powers, you add the exponents. So this is equal to a to the what power?
7.
7. A to the 7th power. Any questions? No. Good. Okay, let's go over the last 2. These are like terms. They're like terms because they have exactly the same variables with exactly the same exponents. If they didn't, they would not be like terms and you couldn't combine them. But since they are, we can. So we have 7 minus 12 is what? And it stays m squared. It's like 7 apples minus 12 apples is negative 5 apples. The exponents only change when you're multiplying or dividing. Because when you multiply, you add them, and when you divide, you subtract them. So that's the only time they change. If you're adding and subtracting, the exponents don't change. Just combining like terms. For number 6, we have to distribute and then combine our like terms. So, first I distribute the negative 3. I'm going to multiply the negative 3 times these 2, but am I going to multiply this times negative 3?
No.
No. Okay? So, negative 3 times 2x is what?
Negative 6x squared.
Negative 6x squared. Then negative 3 times positive 5x is what?
Negative 15x.
Now I'm done distributing here. So now I'm going to move over here and I'm going to distribute this. Positive 2 times 4x squared is? Good. Positive 8x squared. And then positive 2 times negative 7.
Negative 14.
Am I done?
No.
I'm not done. Bogdan, why am I not done?
Because negative 6x squared and 8x squared are like terms, so you have to combine them.
Very good. So these are like terms. I need to combine them. Bogdan, what is that?
Negative 2x squared.
It is 2x squared.
Oh, I actually got that.
Good. So it's positive. It's positive because they're different signs. So you subtract the numbers and take the sign of the larger sign. So it's positive 2x squared. Do I have another like term with negative 15x?
No.
No. So I just write negative 15x. Do I have another like term with negative 14? No. So I just write negative 14. And that is as simplified as I can get that, because I do not have any more like terms. Any questions? Good. So put your warm-ups up and take out some paper so we can take some notes on lesson 6-3. Okay, so the first thing we're going to talk about is the degree. of a polynomial or the degree of a term, of a certain term. So some of your homework questions will ask you, what is the degree of this polynomial? If it's just a monomial, what is a monomial? Somebody raise your hand. What is a monomial? Yes. It only has one term. A monomial only has one term. If it's a monomial, it's the highest sum of all the exponents on that term. The degree is the highest sum of all exponents on the term. And we'll look at a couple examples. So here's example 1, 4x squared y squared. 4x squared y squared. How many terms is that? Terms are separated by pluses and minuses. So, how many terms is this? 1. This is only one term. If it's one term, what is it called? A monomial. Okay? The degree of it, you add up the exponents. So that is a 4th degree monomial. Yes?
In the degree, we just put 4 or we just put 4?
You just put 4. Next example. 2x to the third plus 5x squared minus 2x equals 4. Now, raise your hand. How many terms does this have? Yes. 1, 2, 3, 4. There are 4 terms. Now remember, this is a polynomial. So the highest degree term is 3. X to the third power is my highest degree term. So the degree of this polynomial is 3. Example 3. 4x squared y squared minus 10x to the 9th y to the 4th. Malik, how many terms does this have?
4.
This is one term. 2. Very good. It has 2 terms. Now, for the degree, it's the highest degree term. So, what is the degree of this term by itself? 4, because 2 plus 2 is 4, right? What is the degree of this term?
13.
13. The higher one is the degree of the polynomial. So the polynomial has a degree of 13. Yes. Okay.
I was just gonna add. Did you add?
I added 9 and 4. I added the exponents. Anybody have any questions? Yes. Well, the degree of this is if this was by itself, the degree of it would be 4. If this was by itself, the degree would be 13. So when you have more than one term, you take the higher one. Okay? Good question. Anybody else have any questions? Jane, you good? Okay, now we've already talked about these types of polynomials. We named them just a second ago, but you need to write them down in your notes. A monomial is a polynomial with just one term. Mono means one. For example, 3x to the 4th. That's just one term. Remember, terms are separated by pluses and minuses. Yes?
What is the polynomial?
I know it sounds counterproductive, but that's the formal definition. Polynomial with just one term. Okay, a polynomial with two terms is called a binomial. Bi means two. For example, 3x to the 4th minus 5x to the 6th. Here's one term, here's your second term. So there's two terms. So that's a binomial. A trinomial has how many terms? 3. Tri means 3. 1, 2, 3. That's a trinomial. In the next section, we're going to factor some trinomials and some binomials. And so when I talk about trinomials and binomials, I want you to understand exactly what I'm talking about. Now, there's no name for anything bigger than 3 terms. If it has more than 3 terms, it's simply just a polynomial. Okay? Is anyone not finished? Okay. Good? Okay, so the next slide is the one that you don't have to copy. We're just going to talk about them. So just pay attention to me. You put your pencil down. We're going to review the rules for exponents. Now, you did this in Math 1 and you did this in Math 2. So we just need to talk about it for a second to refresh your memory. Okay? So, we said when you multiply powers, you add the exponents. So on your little sheet, it gives you a little example. So on your sheet, it gives you a little example. X squared times x to the third, you add them, is x to the fifth. If you raise a power to a power, you multiply them. So x squared raised to the third power, you multiply 3 times 2, and that's x to the 6th. Y'all remembering this? Yes, good. If you have more than one thing raised to a power, you take each thing individually and raise it to that power. So x squared y to the 5th, if all of that is raised to the third power, it's like saying x squared to the third power, and we know from the previous rule, you just multiply those powers. So 3 times 2 is 6, and then y to the 5th raised to the third power is 15. Y'all remember that? Yes. Okay, good. If you have a negative exponent, now this might be something that you might not remember. If you have a negative exponent, in order for you to make that exponent positive, you move it on the other side of the fraction. Okay? So if you have x to the negative 3, if you want that 3 to be positive, you put it in the denominator. And then it becomes positive 3. So that's 1 over x to the third. Anything raised to the 0 power is equal to 1. Anything raised to the 0 power is equal to 1. And lastly, when you divide powers, you subtract the exponents. Okay? So these are just some, you have a quick handout, so you can reference that. If you forget, you can go back and look at it and remember what to do. Okay? Now, let's look at our first example. Now that we got through all the fun stuff, let's get to the really fun stuff. Four a to the third plus 2a squared minus 7a. All of that plus negative 3a to the third minus a squared minus 4a. So we're adding polynomials.
This is what they should be writing down, right?
Yes, this is what they should be writing down. Absolutely. Now, we're combining these polynomials, right? So, anybody have a guess on what we need to do? Say it again. Yes, if there's a plus in between these two sets of parentheses, we don't need the parentheses. We don't need the parentheses. So we rewrite it without the parentheses. So that's 4a to the third plus 2a squared minus 7a. Do I have to put plus negative 3a to the third? No, what can I put? Just minus 3a to the third minus a squared minus 4a. Yes?
Why are you putting those three?
Because plus negative 3a to the third is the same thing as minus 3a to the third. Because let me ask you this. What is the sign of this 3a to the third? Negative. What is the sign of this 3a to the third? Negative. Okay. Keandre, what do you think we should do now? Combine like terms. Very good. Now remember, for them to be like terms, they have to have exactly the same variables with exactly the same exponents. Good. So, Tito, what's a like term with 4a to the third? Okay. Can you see it?
Starting with this order.
Negative 3a to the third.
Yeah.
Okay.
I couldn't find it. I knew it was there.
4a to the third and negative 3a to the third is what? 4 minus 3 is 1. Very good. So it's just a to the third. Now, Tajay, what's a like term with 2a squared? Negative a squared. So today, 2a squared minus a squared is just a squared. There's always an assumed 1 there. So 2 minus 1 is 1. So that's just plus a squared. And then lastly, we have negative 7a. Kyle. Where's Kyle? Kyle, what is a like term with negative 7a? Negative 4a. What's negative 7a minus 4a? Negative 11a. So that is my answer. A to the third plus a squared minus 11a. Any questions? No? So you can start copying example 2, and then we'll talk about it. I'll make them a little bit bigger to help you see. So, the first thing I need to do, Chris, what do I need to do here? Distribute the negative 3x squared y. So I need to multiply all three terms by negative 3x squared y. So let's do that. Negative 3x squared y times 2x. Multiply your whole numbers. Negative 3 times 2 is negative 6. X squared times x squared is x to the 4th. And then I don't have anything to multiply y by, but it doesn't go away. It's still there. Okay? Now I multiplied. I've already done that one. So if it helps you to keep it organized, to cross it out after you've multiplied it, you can go ahead and do that. So negative 3x squared y times x. I'm going to multiply it times this now. So, what is the coefficient in front of here? 1. Very good. There's always an understood 1. So negative 3 times 1 is just negative 3. X squared times x is x to the 3rd. You add the exponents. Remember, there's an understood 1 right there. So 2 plus 1 is 3. So that's x to the 3rd. And do I have anything to multiply times y? I don't have anything else to combine with y, so it just stays y. Okay? We're done with that one. Now we're going to do Negative 3x squared y times negative 5y. Very good. Negative 3 times negative 5 is positive 15. Do I have anything to multiply times x squared? No, so x squared doesn't change. It just stays x squared. And then I have y times y, which is good, y squared. Now I'm done with that one. Now we need to distribute the 3x squared y over here. Okay? So y'all go ahead and do that. And we're going to come around and check to see that you're getting it correct. Yep. Good. Okay. So, check your work. Negative 3x squared y times negative 9x squared is negative 27x to the 4th y. Everybody good? So I'm done with that one. 3x squared y times 6x. 3 times 6 is positive 18. I have x to the 3rd y. Questions? No? And then I have 3x squared y times y. So I just have 3. I don't have anything else to multiply times 3. X squared, I don't have anything to multiply times x squared. And y times y is y squared. Siri, what do I do next? Tito, what do we do next? We can't distribute. We don't have anything left to. That's okay. Keandre. Combine like terms. Good. Combine like terms. Okay. So first we need to identify what our like terms are before we can combine them. When we combine like terms, do our exponents change? No. Our exponents don't change when we combine like terms. Okay. So we have an x to the 4th y here, and an x to the 4th y there, right? So that means they're like terms. They both have the same variables and the same exponents. So we can combine their coefficients. That's the numbers in front of them. So negative 6 and negative 27 is what? Negative 33 x to the 4th y. Okay? Yes. The exponents have to be the same as well. They're not alike if they're not exactly the same variables with exactly the same exponents. Okay? So we've combined those. So on these big long problems, what I do is I cross them out so that I don't accidentally combine that with something else again. Okay? You only combine it with something once. And so our next set of like terms, we have x to the third y and x to the third y. So we have negative 3 and positive 18 is what? Positive 15. So positive 15 x to the third y. Everybody good? Anybody have any questions? Okay. And our last set of like terms, x squared y squared and x squared y squared. So we have positive 15 and positive 3 is what? Positive 18 x squared y squared. And I forgot to cross out these after I combine them, but that's okay. And so that's it. It's simplified. I can't, there's no other like terms to combine, so that's as small as I can make it. That's as compact as I can make it. Okay? Any questions? Okay, copy down example number 3. This has a minus in between it. The other one had a plus. The example number 1 had a plus. This has a minus. So we need to talk about how that changes this polynomial. In the example before, when we were combining two polynomials, they had a plus in between them. So we just removed the parentheses because it didn't change either one of the polynomials, right? This has a minus in between it. So if there's a minus in between it, what does it do to this polynomial after it? Yes? It changes the sign of every term. Does anybody know why? Yes?
It's like it's negative 1 plus 1.
Very good. It's like, that's okay. It's like, there's a negative 1 right there. It's like distributing a negative 1. That is why it changes the signs of everything in that polynomial after it. So, we're going to rewrite this without the parentheses, but each one of these terms is going to change signs. So we have 2x squared plus 3x. Instead of a positive 3x squared, it's negative 3x squared. Instead of a positive x, it's negative x. And instead of a negative 4, it's positive 4. Okay? Brianna, what do we do now? Combine like terms. Very good. We combine like terms. So, John, what's my first set of like terms? 2x squared and negative 3x squared. And what is that? Negative x squared. Because it's negative 1x squared. Tito? What's my next set of like terms? 3x and 3x and the negative x. Because they're both x terms. Okay? So 3 minus 1 is 2. Good. Good, Tito. So 2x. And what do we have left? Very good. Plus 4. Okay? So we're done. Any questions? Yes.
I thought there were imaginary exponents behind that. So we're just plus or like square.
No. When we're adding or subtracting, our exponents don't change.
Oh,
Okay? Only when we're multiplying or dividing do the exponents change. Never when we're adding or subtracting. Okay? Good question. Any other questions? Okay? So I want you to try these, and I will enlarge them to make them easier to see. I want you to try these. Oh, what's that raise? No. Okay. Tuesday, yeah. I'm gonna try. Raise your hand when you're done so I can come check and see if that's right. Good. Good. Are you ready? Yeah, so you have to, there's a plus in between it, so you can just remove the parentheses. You need to find the right term. I'm coming, Chris. Make my way there. Oh, okay. You usually want to go in descending order. Good. Oh, that's negative x to the fourth, negative x to the fourth. Should be 4x.
Oh,
Because you have negative 5 and positive 1. You usually put your answer in descending order, starting with your highest exponent on down. Yeah, that's right. Yes. Yes. So you can combine them. -7 and +6. Gives you a -1. That's right. But your x to the third, you have 1x to the third and -5x to the third. So when you combine -5 and +1, it's -4. So you have, this is a positive 1, this is a negative 5. So 1 minus 5. Leave your x to the third. That's those even if you didn't know what it's going to be, 1 minus 5 would be -4. This would be -4. And then your x to the fourth is -7. Oh, yeah. And then you have 2x plus 1x is 3. Okay, let me do it and see. You can check your answer, okay? Because it looks like everybody's just about finished. So, there's a plus in between it. That means I'm not going to be changing any signs. I'm just going to be combining like terms, right? So we have an x to the third term and -5x to the third. So this is like 1 minus 5 is -4x to the third. Then I have x to the fourth. So x to the fourth and negative 7x to the fourth. 6x to the fourth and negative 7x to the fourth. So 6 minus 7 is negative 1x to the fourth. So I put that one first because you want your variables in order from their highest exponent down to the lowest. Now, if you have it mixed up, the answer is still technically correct. It's just in a different order, okay? And then we have 2x and 1x is 3x. So somewhere in your answer you should have a negative x to the fourth, you should have a negative 4x to the third, and a positive 3x. Yes?
Are you always going to want to split it into the terms?
Yes, because that's the way you're going to be used to seeing it. Okay? I wouldn't mark it wrong if it was mixed up. Because technically it's not wrong. Unless the directions say, put in these in order. Okay? For number 2, we have to distribute. First, we have to multiply this by 7x to the third y squared. So, 7 times negative 2 is negative 14. X to the third times x to the 1 is x to the fourth. Y squared times y to the fifth is y to the 7th. Okay? Then I'm going to distribute. I'm going to multiply it times this one. I'm done with that one. So 7 times 3 is
21.
positive 21. X to the third times x to the fourth is x to the, you add those exponents, so it's x to the 7th. Y squared times y to the third is y to the 5th. And you're done. Multiplying polynomials is just distributing more than once. That's all it is. How many of you have heard of FOIL? Okay. Well, we're not, FOIL is basically what we're going to be doing, but we're not going to reference it as FOIL because you don't need to know some kind of neat trick in order to distribute. You just distributed right here. You already know how to distribute, right? So, let's look at example 1. Okay, so we're taking this and multiplying it times this, right? Because there's multiplication in between those two. So, in this problem, I'm going to distribute how many times? 2 times. First, I'm going to distribute the 2x, so I'm going to multiply both of these by 2x. Then, I'm going to distribute the 3. I'm going to multiply both of these times 3. That's all we're doing. And then combine like terms. So, first, I have to take 2x and multiply it times 5x minus 1. And then I have to take 3 and multiply it times 5x minus 1. So we don't need to remember what FOIL stands for. We just take in turns distributing. And then we're going to combine everything, right? So first, we're going to distribute this 2x. So we're going to multiply both of those times 2x. So 2x times 5x is what? 10x squared. 2x times negative 1 is negative 2x. Okay, so now, what are we going to distribute? The 3. So we're going to multiply both of those times 3. 3 times 5x is 15x. And then 3 times negative 1 is negative 3. Then we just combine our like terms like we just did. We combine our like terms. So, do I have another x squared term? No. So that stays 10x squared. But I do have 2 x terms that I can combine. Negative 2 and positive 15 is what? Positive 13x. And I don't have anything to combine with the minus 3, so it just stays minus 3. If I would have had 3 terms over here, It would have been the first term times this, plus the second term times that, plus the third term times that. It doesn't matter how many terms they give you. You just distribute them one at a time. Does that make sense? Okay. One of the biggest problems in Math 3 is that people don't distribute correctly. Okay? And it shouldn't be. It shouldn't be a problem. Now, in example 2, we have 3x minus 5 squared. Let me ask you this. If it was x squared, is x times x, right? 7 squared is 7 times 7, right? 32 squared is 32 times 32. So, 3x minus 5 squared is 3x minus 5 times 3x minus 5. So before you can do anything, you have to expand it. If it was to the third power, it would be 3x minus 5 times 3x minus 5 times 3x minus 5. Okay? So now that you've done that, go ahead and finish number 2. Okay, now, I know some of you are good at this, and you can just look at it and go 3x times this, times this, times this, times this. But some of you need to be a little more organized because it's easy to make a mistake. So write it out. First, you're going to distribute the 3x. So 3x times what? 3x minus 5. What do I distribute next? The negative 5 times 3x minus 5. Now, go ahead and distribute and multiply it out. You will lessen your chance of making a mistake if you do this first. So, 3x times 3x is 9x squared. 3x times negative 5 is... I'm done with that one, right? Now we'll do this one. Negative 5 times 3x is? Negative 5 times negative 5 is? Now what? Combine your like terms. So my x terms are my only terms that are alike. So I have 9x squared. Negative 15 minus 15 is what? Plus 25. Now, what would happen if we had something to the third power?
You do it 3 times.
Right. No, you cannot times it all by 3. Nope. Nope. So, we rewrite this, we expand it. That's x squared minus 4x times x squared minus 4x times x squared minus 4x. Now, let me ask you this. If I said 2 times 7 times 10, you would work your way from left to right, correct? You would do 2 times 7, and you would get 14, and then you would multiply that times 10, right? This works the same way. So, you're going to take these two, multiply those together. Pretend like that's not even here right now. Multiply those together, combine your like terms, get your answer. Then you're going to take that answer and multiply it times that. Just like we did when it was numbers. You multiply the first two, get the answer, then multiply it times the third. Yes?
And you do all 3.
You cannot do all 3 at once.
So you have to do it.
You have to do it like this. You cannot do all 3 at once. Because you can only distribute one thing at a time. Okay? So, we're going to do these two. So pretend like that piece isn't even there. Okay, so first we're going to distribute the x squared. So we have x squared times x squared minus 4x. And then we have negative 4x times x squared minus 4x. I'm just not worried about this right now. Once we get our answer, I'll bring that down and we'll multiply that. Okay? So, let's do this. First, I need to distribute the x squared. X squared times x squared is x to the 4th. X squared times negative 4x is
It's negative 4x cubed.
negative 4x to the 3rd. Okay? We're done with this one. Now I need to do this one. Negative 4 times x, negative 4x times x squared is,
Negative 4x cubed.
and then negative 4x times negative 4x is,
Negative 16x squared.
good, positive 16x squared. My like terms, I need to combine them. So, I have x to the 4th. Here's my like terms. What is that? Negative 8x to the 3rd plus 16x squared, right? So that is my answer when I multiply these two together, correct?
Yes.
So this is the answer when you multiply the first two. Now we need to take this and multiply it times the last one.
So just bring it in.
So you just bring it down. Times x squared minus 4x. And then we do the same thing again. What's the first thing we distribute?
The
X to the 4th. What am I multiplying that times?
x squared.
X squared minus 4x. Then I'm going to distribute the negative 8x to the 3rd. I'm going to multiply that times x squared minus 4x. Then I'm going to take 16x squared and I'm going to multiply it times x squared minus 4x. So is this a long problem? Yes. However, it's not difficult calculations. Okay? So, first we distribute the x to the 4th. So equals x to the 4th times x squared minus 4x. Then we distribute the negative 8x to the 3rd. So negative 8x to the 3rd times what? X squared minus 4x. What do I distribute the next?
16x squared, 16x squared.
So plus 16x squared times
X squared minus 4x.
x squared minus 4x. Distribute, combine your like terms, and you'll be done. So first, x to the 4th times x squared is x to the 6. X to the 4th times negative 4x is negative 4. X to the 5th, because you add those exponents. Now we do the negative 8x to the 3rd. Negative 8x to the 3rd times x squared is
Negative 8x squared.
Tito. Tito. Seriously. Negative 8x to the 3rd times x squared is negative 8x to the... Negative 8x to the 3rd times negative 4x. Malik, what's that? Negative 8x to the 3rd times negative 4x. What is that? Negative 8x to the 3rd times negative 4x. Good. Positive 32x to the 4th. Malik, what do I distribute next? What do I distribute next?
16.
16x squared. What do I multiply it by? Good, stop telling it, Chris. Malik, 16x squared times x squared is what?
16x to the 4.
16x to the 4th. Malik, what do I distribute next?
The 16x to the 4x.
And 16x squared times negative 4x. What's 16 times 4? What is it?
16 to the 4.
Positive or negative?
Negative.
And that's x to what power? Woo! Yes. That was a long problem.
That's it.
Nope. But now we just have, okay, well this is really long. I can shorten it because I can combine my like terms. I see 2x to the 5th, so I see 2x to the 4th. So, combine your like terms. I don't have another x to the 6th, so that just stays that. Negative 4, negative 8 is
12x.
positive 32 and positive 16.
48.
And then I don't have anything to combine with that. Woo! So, yes, this was a long problem. But all it is distributing. You just have to take your time and distribute. Take the first two, multiply them together, get that answer, and then multiply it times the third one. Any questions?